Good afternoon and welcome back. In this lecture we will be running through the GetDirection function that we've predefined. I also wanted to mention that regarding the naming convention for the videos that I will be putting up, for the most part I will be trying to name them as either the function that we're making, or I will be keeping each video specific to a section of code, and the names will reflect the comment that I give the code. So just so in case anybody gets stuck at a certain point, or there's a certain section of their code which isn't firing properly, that should hopefully allow you to go back to the video named for the comment that the section you're currently in. It also means that if you're coming to the chat section and asking for help or discussing anything, it might make it a bit easier to just say, I was on the spawn animation and X didn't work, or when I did the movement section, did I put this in the right place? That type of thing. Just so you know, the names that I give everything is not going to be completely random. There is some logic behind them. So yeah, just keep that in mind. So for this one, the GetDirection will be the function we're focusing on today. What we want to do first of all, as I did say, that each function that we make, unlike the events, will have their own event graph or their own graph. So if we double click on this, we will be taken to the graph for the GetDirection function. Now this is the start node for the GetDirection, and what we can do with this, if we select the beginning node, we can give it a number of inputs and a number of outputs. We actually want to do this, so this just means that we can not only call a function, then we can pass it a value to use inside of this function. So it doesn't need to necessarily know what that value is. It's just going to be given a value, and then it's going to do an equation on it based on what we want this function to provide. And the way we do this, as I said, we select this and click on the new under the inputs and give it a name. So the first one I will call speed, and this will be of type float, and the next one will be direction. Direction will also be of type float. So we can now see that there are two inputs. And so this makes sense before we go any further. What this means now is if we go back to the event graph, we have two input nodes to provide the user. And what we can do with these is the values that we have in the main event graph, we can now plug in here when we call the functions, because this will be what allows us to use a function in more than one way, but using the code that we'll be putting in there and only using that code once. So the way we'll use this, the first one will be controlling the vertical movement. So the speed that we're interested in is the vertical speed, and that is based off of, remember, the direction will be the move up direction. So we can just copy that from over there and we can plug that in there. And now we're going to do the same thing almost. We're going to now get the horizontal speed and put that in the speed there. We can move down here again and get the get move right and plug that into the direction there. And that means that each time that this function is called, something slightly different is being passed into it. And this is what will allow us to set up the movement of the set actor location in a moment. So for now, if we go back into the function, we also want one other thing. So if we select this again, we also want an output, and the output will be a float, and this will be I'm going to call this return direction. The reason I do that is because it is what's classed as a return node, so I just prefix it with the word return. And what it's returning is the direction that the ship is moving, or the direction that needs to be updated at least. So for this, we're going to get the vertical speed, and we're going to plug the first one in there, so that's the vertical speed done. And here we will get the horizontal speed, and that will then update the horizontal speed. So that's back in the event graph, and then if we go one last time back into the GetDirection, we now want to do some equations between the GetDirection and the return node. And what we want to do, first of all, if we drag off of the direction, we will multiply a float by a float. That float will be times by the movement speed. We will then multiply another float by another float, and this will be our locally tracked delta seconds value. So again, this makes it frame rate independent, so the movement will also be exactly the same regardless of which system you play it on. And finally, we want to get the speed, and we will drag off an f_interp2 in fact. And then just to explain what this is, the best way I think I can do this is if we highlight this, it just describes it as the f_interp2 tries to reach the target based on distance from the current position, giving a nice smooth feeling when tracking a position. So that's really what most interpolations do. They try to smooth out the movement between point A to point B. So with that, the return value will go into the return direction. The target will be based on the equation that we've just made here, so that will plug in there. And the delta seconds, if we just copy another, we can just drag that from here in fact, so that will be the delta seconds. And the interpolation speed, again, it's quite nice, set it 4. So what this is doing, we have the movement speed, which is our constant 4000 speed. We can see that here. So the first time this is called, if we remember, the first time is regarding the vertical speed. So this will take the direction, which is vertical speed, and times that by movement speed. So movement speed is being times by 4000, and it will times that by delta seconds to make this frame rate independent, and then it will take the speed, which is the current speed, and it will interpolate between the target and the delta time, and the return of that will give us the vertical speed update here. This is really important to understand if this is the first time you've seen functions. It's really important to understand why this is such a good way to do things. Oh, and I realise actually, whilst I've been saying that, I've missed a step. So we also want to drag off of here, move it over here, and we will set the current speed. So if we get the current speed, as I said, that will link between the return node, the GetDirection. It will fix the link we were going to break, and we want the return value to be the current speed, and we want the current speed to be the return direction. There we go. So sorry, it's doing everything I just mentioned, as well as setting the current speed of the player's movement. I thought I was missing something. So yeah, back to the idea of functions. If this is the first time you're seeing functions, these are really powerful, because when I said that it doesn't care what this value is, this is just an empty value when we made these input values. So speed and direction can be anything, which is why this is great, because we have a kind of generic equation function going on here. And what we can do is we can call that in different circumstances. So we can call that once for the vertical speed, and we can call exactly the same thing again without making any changes to it for the horizontal speed. And the reason we don't need to make any changes is because the blank slate variables that we have ready for the inputs can be the thing which gets changed when you call the function, which is what we're doing here. And the same for the return values, is that these will be the bits which are changed after the function. So the function can stay exactly the same. And the other important thing is what I mentioned earlier, is that the alternative to what we've done now using a function would be that these essentially want exactly the same outcome. So without the function, what we would have had is, and I recommend not to copy this right now, is we would have had something that looked more like this. So to do it the first time, we would have had one set of these nodes taking in the vertical speed, so put the vertical speed in there based on the movement which we're doing down there. We then would have needed the exact same thing again, but just for the horizontal speed, and then getting the get movement on there as well, and then returning that with the vertical and horizontal speed. And it's not even a big function, but you can already see that that saves more space and is easier to read than these two things combined. And as we go through the project, we're going to be making functions which are a lot bigger and more complex than this as well. So again, if you can imagine that they're being called a few times in each blueprint, and if you had to blueprint those things out each time separately, it's going to start taking up a lot more room. It's going to take a lot more management when you have to go back through the code to try and fix things if something goes wrong, because it's quite likely either you're going to break it in each time that you do it separately, or even more confusingly, you might be doing the same thing 3 times, but the second time you did it, you might miss something out. So then you're going to wonder why that isn't working when the other two are, and they're exactly the same. Whereas with this, we're only doing it once. So if something breaks in here, it's only going to break that once, and then we're going to fix it, and we should never need to see it again. The only things we need to then concern ourselves with are the values which are being passed into it. So that is the prime concept behind functions. It's why they're really useful. In fact, they're pretty much invaluable, and most of the blueprinting we'll be doing will be trying to use functions wherever possible and wherever they fit best. So that is the movement functionality done. If we press compile and save, what we should find now is that we can now move our player around the level. I can definitely move him backwards and forwards, and he's doing the veering, but some weird movement stuff there, so I've done something wrong. So there we go. As I said, something's going to go wrong at some point, and I will fix it as and when that comes up on the video. So if you have the problem we just saw there, I can only move back and forward. We'll just debug through this now to work out why. So this to me looks correct. We're getting our vertical speed, and the return value is the vertical speed. We're setting that to be the current speed. We have the move direction, so we're updating the correct value there. Okay, so that means our problem is quite likely to be further back here. So the move up is controlling vertical, so vertical is up here, and move right is horizontal, being controlled correctly. So, okay, I see what it is. So we're not trying to move the y-axis when we're moving up and down. In the previous lecture I remember changing that, and I'm not 100% sure why. So that should actually be all the problem was. So if we compile and save that, Z is controlling up and down the screen, Y is left and right, X is back and forward, so bring it closer and further away to you. So yeah, that's all it was. So we now have our nice swoopy veering movement when we move up and down the screen. We can fly it at the moment because we haven't set the collision for the walls, but that's something I have planned for later, and we can move backwards and forwards properly. I also wanted to do a very quick demo. So if we don't set the relative rotation, that's what it looks like if we don't have the veering movement. So I mean, it still looks functional, but just making this one small tweak and adding this in, how much better does that look? Just brings the game to life a little bit more. So that's the sort of thing that I want to focus on as we go through this series, and I will mention it whenever possible, just so that these kind of concepts and theories start becoming more ingrained in your development cycle as well. I think they're very useful to know. But there we go, we now have a moving player ship in the game, which I think is really cool. We have all of that ready, and it only took 2 lectures really to get that done. So we can wrap the movement stuff up here, and we can start moving on to the creation of the projectiles, or of the projectile implementation. And that means we can start moving on to the projectile implementation and fleshing out some of the functionality for the event that we had down here. So I look forward to this, and I will see you in the next lecture.